So we'll go ahead and continue with saturation and solubility curves. Let's run through these pretty quickly. It shouldn't take us too long. So a super saturated solution, so super means that it contains more than the maximum amount of solute at certain temperatures. I continued this question and said, how do you make a super saturated solution? Remember, this is when we spoke about sweet tea. Okay, so we were talking about sweet tea. So with sweet tea, when we're dealing with, so you don't have to write this part down if you don't want to, unless you just need to write a drawing or have a picture of it. It's in your notes. We did draw it out, okay? But basically your grams of solute and your temperature, it increases as we're increasing temperature. So when you're making sweet tea, your first step is to crank up the temperature. So heat it up. Then you're going to basically get it at this temperature. You're going to add solute to the maximum amount. At that point, you're going to cool it down. And now you have a supersaturated solution, something that's well above where the curve is. Okay, so it's not just a matter of adding, because it's not going to happen. It's going to fall out of solution. Okay, you had to heat it up, add it, dissolve it, cool it down. Okay, and that's kind of what that little hot pack was that I walked around with. Add solute to the max. Sorry. All right. So that's a supersaturated solution. A saturated solution contains equal to the maximum amount of solute at a certain temperature. This means that as you add more solute, it will not dissolve. It will no longer dissolve. It will fall down to the bottom. That's why you have to heat it up if you're trying to make a supersaturated solution. Okay. An unsaturated solution is something that contains less than the maximum amount of solute. At a certain temperature. This means that as you add more solute, it will dissolve. So as you add more solute, it's not going to fall down to the bottom. It's just going to keep dissolving in the water. And then we have our 3 examples of where our dot is. So this is that part where I was saying, you know, when you're comparing where the dot is to the line. So this is above the line. So this would be supersaturated. This is unsaturated. And the last one is saturated. Okay. You should have in your notes a prettier image of this. It's a little bit bigger. So if you're really having a hard time seeing this, then I would take out the notes that have it. Otherwise, you can draw in what we had wrote in our notes, which was have the 4 quadrants. Okay, and basically this corner, write down this list, right? So it's soluble, which means the state of matter is aqueous. It's dissolved. Down here, this is insoluble, which means it was solid. Okay, so insoluble meant it was solid or a precipitate. So we would read, hey, it's soluble, and then we had to consider the exceptions. So if you end in this list and you're soluble or insoluble, then if you have an exception, you're switching. So if I start out soluble, but I have one of the exceptions, I just made myself insoluble, which would then be the solid or the precipitate. Down here, I start out insoluble unless I have an exception, and if I do, then I'm aqueous or soluble. The other thing that we added to our notes was we talked about the alkali metals. Those alkali metals, those are group 1 on our periodic table. group 1. So you might remind yourselves where to find group 1. Group means the column, so the first column on the periodic table. Okay? All right. So I'm going to go through a few of these, and then I'll probably leave some of them for you. That way I can cover the rest of it, and you guys won't run out of time. So when you're using your solubility rules, you're looking at the anion. The anion is the second thing listed. Just like when we were writing ionic compounds, we would write metal and then an anion. Metal and then an anion, right? So it's always the second thing listed in your compound. You find it on your chart and you start there, okay? So for example, on the first one, we have CH3COO, which looks really overwhelming. You're like, what is that? But if you look at your solubility rule chart, it's the first thing listed, CH3COO. So you start out here. That's acetate. Acetate is soluble or aqueous unless it's with, and then you look over here. It has no exceptions to that rule. So that means that it's aqueous or soluble. Okay? All right. NaOH, we're looking at the OH, hydroxide down our list. So we're going to look down our list, down our list, down our list. Hydroxide was down here. So hydroxides are insoluble. Unless it's with NH4, group 1, or CASRBA. So here it's with Na. Na is group 1. Na is group 1. So therefore, it has the exception. I'm going to be aqueous or soluble. Okay. Okay. Number 3, copper nitrate. So I'm going to look for nitrate. Look down my list. Nitrate is up here. So nitrates are soluble or aqueous unless it's with, there's no exception to that. So it's soluble. Okay. The next one we got is sulfate. So we're going to look down our list for sulfate. Sulfate was down here. Sulfate is soluble unless it's with strontium, barium, lead, or mercury. Look at this. It's with barium. So we just moved to this side, which makes it insoluble. Okay. Kind of looking ahead down here at precipitate. What are we going to say for that one? It's solid. So is that insoluble or soluble? Insoluble. And then aqueous means that it is soluble. Okay. So question 13 was straight from your lab. All right. So I'm not going to ask you to write this out on a test. But I am going to present you with a reaction and ask you to tell me what is the precipitate, what type of reaction it is. So we're going to go ahead and set ourselves up for that kind of question. So we have AgNO3 plus NaCl. When they come together, we would switch the cations. That's your hint, by the way. NaNO3 plus AgCl. So both of these had aqueous, right? So both of my reactants were aqueous, just like in our lab. We mixed 2 aqueous solutions and we made a precipitate. Which of these 2 is the precipitate? And you have to look up each of their compounds on the solubility rule chart. So this one we have a nitrate with a group 1. This one we have a chlorine with a silver. So out of those 2, which one is going to be a insoluble solid? Insoluble solid. Exactly. Yep. AgCl. This one, nitrates, group 1, always going to be soluble. All right, so AgCl is your precipitate. Okay. And type of reaction. You've got to know this one. So it was the very first question on your lab. What type of reaction are we looking at here? You got synthesis, decomposition, single replacement, or double replacement? Double. Good. Always. Your precipitate ones, yep. Okay. All right. We're doing okay, guys? All right. So